Hello, welcome everyone to Computer Skills module. I'm your instructor, Dr. Murat Tunç, and today we are going to start our very first lecture on computer skills. We are going to have 4 lectures, and each lecture will talk about how to write a program, a computer program in Python. I hope that you guys are all motivated and interested to learn how to write a computer program because nowadays we are connected through everyone, especially after the pandemic. Everyone seems to have been connecting and working through a computer, and most of the times you are using some software uh, without actually knowing how to program them. But in this class, you're going to learn how to write a computer program. I think it's important, especially because in today's world, so 8 billion people connected through a computer system, computerized information system, and I think it is actually a really great skill for you to learn computer programming throughout college, and after you graduate, it's going to increase your chances of finding a good job and land you, hopefully, in your dream position in the industry. Or if you like to continue in academia, that's also a great skill. So you are throughout your undergraduate career, undergraduate education, you are going to be using some statistical software, for instance, where you're going to write small pieces of computer programs to run certain statistical estimations, for instance, regression, or sometimes you are going to be asked to, use some data set, existing data set, to make sense of what is going on in certain businesses or certain countries. To do that, I think computer programming is a great handful skill, and I hope that you guys are all motivated to learn computer programming. If not, that's not a problem, because here is a video, YouTube video. If you actually go and click on this video, you'll land in this YouTube page. So this YouTube page, if you actually click press, it is around a 6-minute long motivation to why programming is important. And there are actually pretty famous people. For instance, the founder of Facebook, Mark Zuckerberg, is giving a small speech. And it starts with this great quote: everybody in this country should learn how to program a computer because it teaches you how to think. I'm not going to run it for you here. I'll ask you to do it at home. And I hope that after watching this, you would be really excited and motivated to learn programming. But in this class, what we'll start with is introduction to computers, programming in general, and Python. I'll introduce you the 3 concepts one by one, starting with computers. I'll divide this lecture into 3 parts, and I hope that you're going to enjoy the lectures as well as learning from this class. All right, let's begin. So what is a computer? I know that you guys all know it, but just be patient with me. So we'll first talk about the computer hardware, and then we'll never talk about hardware again. because all we are interested in would be the computer software. That's where we write our programs, right? So a computer is an electronic device that stores and processes data. So it does two things basically. It stores all the information and it processes for the human who uses it. It consists of hardware and software. So as I said, we'll first start talking about hardware, but this is where we would be all interested in the software, how to write a software program. But we are going to start learning and understanding hardware mainly because it affects how fast your software will run. So unless you have a good understanding of a hardware, it's going to be difficult for you to have a good understanding of how fast your software will run through this hardware design, okay? So we'll start with computer hardware. So a computer consists of components. So each box here is a computer component. So this one. So they're all components, and they're all interconnected with each other with a system called bus. So all of them communicate with each other through this bus system. So from here, for instance, from the storage devices, you have a connection to output device from this bus system, right? And we'll start talking about each piece and each component one by one, starting with central processing unit. So a central processing unit is a short CPU. So this is basically the computer's brain. It retrieves instructions from memory and executes them. So it has two units, the control unit and the logic unit. And we measure how fast the computer's brain is, the CPU is, by something called gigahertz. So most of these laptops that you purchased recently or since last 5 years, the latest CPU clock is around 4 or 8 gigahertz. And next to talking about CPU, we are going to learn something called bits and bytes. So this is really critical because this is the fundamental learning in computers, about computers. So computers, how does it work? Like it's like magic. So you press something on your keyboard, or like if you click on something using your mouse, it does something for you, right? So like how does it understand and how does it make me use it and do the things that I ask him to do, right? So this is I'll tell you how. So inside computers, small chips. So there are basically really small, like nanoscale small wires. So a wire is where the electricity passes by. It's like electric wires. And the computer has like millions of them, right? Billions of them. And a wire can have electricity on if an electron passes by through this wire, or if there is no electron, it's going to be zero. So each wire can be either one that is on or off. If there is no electricity, it is zero. If there is electricity, then it is one. So when you click on your mouse, these electrons changes states. So for instance, before you click something, maybe it was like 1001, and maybe after clicking becomes 0101. So after this change from this to this, computer actually does something, because these instructions 0101 is what computers understand, and we call them a binary digit. Okay, short bits. So binary stands for either 1 or 0. So this is a binary digit can be either 0 or 1, as we learned here. So it's either on or off. And data of all kinds, such as numbers, characters, strings, they're all encoded as a series of bits. So they're basically a series of bits. For instance, the character J, right? So if you press capital J on your keyboard, and when you see it on Microsoft Word, so what you see is capital J. What the computer sees it is 01001010. So this is what capital J is for the computer. And this is actually, so if you actually count it, so like 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 bits, right? So this is called a byte. An 8-bit, 8 binary digits as a series, it means byte. So we define it as a byte. And the minimum storage unit in a computer is a byte. Okay? But of course, we don't talk about bytes because they're so small. We talk about kilobytes, megabytes, gigabytes, terabytes, right? And they're a multiplicate of 1,000 to each other. So for instance, a kilobyte is 1,000 byte, megabyte is 1,000 kilobyte, and so on. All right, so this is how CPU works. Let's talk about the memory. Okay, so memory stores the data and instructions, program instructions for CPU to execute. So a memory unit is an ordered sequence of bytes. And so we call the memories random access memory, or in short, RAM. So sometimes if you purchase a laptop, you talk about how big is the RAM, right? So this basically you're talking about how big the memory is. And why it's called RAM, but not just like memory, because so you can access memory randomly. So although it is a memory unit is ordered sequence of bytes, you don't have to go on them one by one to reach out J, for instance. You don't have to pass A, B, C, D, E, F, G, and H, and then go to J. You can directly go to J, passing by all the prior characters. So that's why you have a random access. So that's why it's called random access memory. And here is a thing: a computer program and its data, they must be brought to memory before they can be executed. So this is actually really important, because so memory is where computer CPU actually acts upon. So a computer CPU, the brain, looks at the memory, and whatever the memory has for it, the CPU executes it. Okay. And then the storage devices, such as, disk, CD, and tape, they no longer exist. All they have is maybe like an external drive. So computer memory, RAM, that's what we just talked about. So it's volatile. So what does volatile mean? The information is lost when we shut down the computer. When the power is turned off, the computer's memory is basically reset. Okay. So like everyone erases from the memory when we restart the computer, for instance. So what do we do then? Because every time we start the computer, it's like we have a new computer. That shouldn't make sense, right? We need some place where we can permanently store our programs, our photos, etc. So the programs and data, so they're permanently stored in the storage devices. Okay, and then moved to memory when computer actually uses them. So, okay, so here is the thing. So you have everything on your storage device, okay? And then when you want to use them, for instance, you have a photo, you would like to show it to your friends, right? When you double click on the photo moves to memory. And then CPU goes to the memory and opens it for you, opens the photo for you so that you can show it to your friends, right? So this is how it works. So they're all stored in storage and then they move to memory when they are about to be executed or used. Okay, and we have the output devices. So that is basically the monitor or the printer where you actually see, uh, you know, uh, your photos. So the monitor, I know you guys probably know it, but so it obviously displays information, text or graphic, and the monitor consists of pixels. Maybe you heard the term, but you don't know what it means exactly. So there are tiny dots. So they're actually square dots. They're like really small. Like there's like these are the pixels. So you don't see them, but on this axis, for instance, we have. I think this is what my resolution is, 1922. Down here, 64. So so there are like almost 2000 dots from this side to the other side. So they're called pixels. So they're actually really small. They're like, I mean, I'll just make them bigger for you. So they are like these square dots, right? Excuse my drawing. So they're like really square dots. And every dot stores an image for you. Okay, so for instance, these dots, these pixels, they store white. Okay, but these pixels, for instance, so they store orange. And these ones store black. And for instance, this one stores blue. So every little dot on your screen has some value or some color. So that's how you see something on your monitor. And the quality of the display is determined by resolution and dot pitch. So resolution specifies the number of pixels in horizontal and vertical dimensions. So for instance, let's say that the pixels, the common resolution for the pixels is 1024 byte, like from here. So this axis 1024, and from here to there, we have 768, right? So the more the number that you have, for instance, the one that I have is actually high quality monitor. So because I have more pixels. So if you have small number of pixels, maybe so they are like bit bigger, so they don't really capture the essence or the details, the small details. But if you have like smaller, like, so instead of 3, if you have, for instance, like 6, you can have the details right. Otherwise, you would have to sort of combine the details into one bigger pixel. So that's why it's not high quality. So the higher the resolution, the sharper and clearer the images, right? So that makes sense. And the dot pitch. So the dot pitch is the amount of space between pixels. Okay, so I've been showing you that the pixels are like right next to each other. Actually, it is not true. They're like a bit far away, but you don't see them because like they're really small. So the dot pitch is the space in between the pixels. So this is dot pitch. And logically, you don't want too much space because that space you cannot control. That space you cannot, show an image because that is blank. So you want dot pitch to be smaller, unlike the resolution, for a sharper display. Okay, so you want high resolution, but you want lower dot pitch for a high quality display. Okay, and then you have communication devices where you are connected to the internet, for instance, through modem. And you have the input devices where you input your needs. For instance, if you want to write, if you double click on some uh, YouTube link, you watch it, and then if you write it to your friends or like to your family, you can also use your keyboard. So that's the input devices. All right, so that's all about computer hardware. So I'll stop the video here. And in the next video, we are going to talk about computer software. Okay, I'll see you in the next video.